And then if I click that button there, again there we go. So we've got X being the number of bag A sold and Y being the number of bag B sold. The objective function is the goal. It's what we want to try to achieve in terms of selling. How much money do you make if you sell X of bag A? $8X. Because you'd earn $8 for each of them that you sell. How much money do you make if you sell Y of bag B? 12Y. Okay. So our objective function is how much money we make is going to be 8X plus 12Y. Now, the objective function is one of these unusual things in maths that it's just like that. It's not equals something. That's what you could probably call it income equals if you wanted to make it an equation. But it's a function, so it's just like that. It's really a algebraic phrase. Okay, so here we go. Next up, we've got this little table that we're going to complete. Bag A has how many chocolates and how many roses? 10. 10 and 6. So let's fill in this information. We've got 10 chocolates, 6 roses. And bag B has 20 chocolates and 8 roses. 20 and 8. And what's our limit there? Elijah, what's our limit? How many chocolates do we have to sell? 129. Have a look. It's up in the top part of our information here. What have we got? 140. So at most, 140 chocolates, and at most, how many roses? 72. Okay. We've put together the information. Good job for following along. Hopefully we're going at an okay speed for people to get some things here. Part 2. The question next in part 2 is, using the above table and the information above, 4 constraints can be used to model this situation. List them below. A constraint is different to an equation because a constraint is going to have these symbols in it. Less than, greater than, or less than or equal to, or greater than or equal to. Okay, we're going to need to use these. Quick recap on these symbols. I always picture it as a crocodile, its mouth. The crocodile always wants to go for the bigger piece of meat, okay? Or the bigger part. So whichever side it's opened to is the bigger number, okay? All right, there's 4 constraints here in terms of X and in terms of the numbers here. Can anyone think of what one of those constraints might be? Is there an equation that we can come up with using those symbols and using X and or Y?
Is this like saying X must be bigger than 0 but bigger than...
It's got to be greater than 0, doesn't it?
Yeah.
You can't sell a negative number of bags. Mm-hmm. That's right. Good. So X has to be greater than 0. Now, can it also be equal to 0? Could you sell none of... Remember, X means the number of bag A. Could we sell none of bag A and just sell all of bag B? Yeah. That could happen. So, as a result, X has got to be greater than or equal to 0. Yeah. Are you able to copy this down? Are you good? Mm-hmm. Able to copy it down? So X has to be greater than or equal to 0. What else? What's another constraint? Y's got to be greater than or equal to 0 as well. Because the scenario tells us that. You can't sell a negative number of bags. It's got to be positive. All right, now we can also come up with some other constraints, and this little table here is going to help us to come up with these constraints. There's some constraints in terms of, firstly, let's focus in on the chocolates. There's a limit to how many chocolates we can sell. We can't sell any more than 140. So the number of chocolates can be up to and including 140. In other words, less than or equal to 140. But how can we write an equation in terms of how many chocolates we might use?
X plus y.
X plus y, have one guess? What was one over here?
X.
X.
Less than or equal to.
X is less than or equal to 140? Let's have a think. If X is less than or equal to 140, bag A has 10 chocolates. So could you sell 140 of bag A? No. Every one of bag A has 10 chocolates in it.
Oh, so does that mean X is less than or equal to
10 times X plus, how many chocolates are in bag B? 20. Plus 20 times Y has to be less than or equal to 140. 10 lots of bag A plus 20 lots of bag B has to be less than or equal to 140. Can you see how this table actually sort of shows us that? 10 times X plus 20 times Y has to be at most 140. There's one more equation.
6x plus 8y is less than 72, equal to 72.
Good, you picked up the pattern. 6x plus 8y has to be less than or equal to 72. Because 6 lots of bag A plus 8 lots of bag B, that's how many chocolate roses are in bag B, has to be less than or equal to 72. Okay? Well, it's like anything, often starting the equations is kind of the tricky starting point here. Okay? So we've got our equations here. Okay? Any questions so far? Go to the next page. Now, as I slide this down, the top part of the page should remain, but sorry that the right-hand side just looks a bit messy. We'll just focus on this left-hand side now, okay? So I'll keep my old working out there. Now, what does it look like on our little recording here? We still got it? We still sort of got it there. Well, that looks funny. Okay. Graph the constraints and shade the feasible region. Label the lines. Graph the constraints and shade the feasible region. I'd like to first show you this electronically. So you can sort of visualize this and see what's going on here, okay? And then we'll actually do a paper copy of it here, okay? Because this time we've got some different things here. We've got greater than or equal to signs. So have a look at my screen here. Let's go here. I'm going to jump into the textbook. And as we jump into the textbook, let's have a look at year 12. All right. Now, do you guys have access to the digital textbook?
Yeah.
So you can actually jump on and do this yourself. There is a hidden in chapter 2 on page 39. There's this linear programming app that you can actually click and launch. And what it does is it nicely shows us this. So I'm just going to drag that across there. Okay, let's type in our constraints. Remember our constraints were x is greater than or equal to 0. X is greater than or equal to 0. See, you have to put like the greater than equal to. There's no greater than or equal to sign. Y is greater than or equal to 0. There. What's next? 10x plus 20y less than or equal to 140. And 6x plus 8y is less than or equal to 72. All right. Have a look at what's going on there. So here's the equations of all these lines. You know, we're told that x has to be greater than or equal to 0. In other words, x has to be positive. So the feasible region of all the results has to be greater than or 0. We're also told that y is greater than or equal to 0, which is this line over here. These two lines here are these two equations. Okay? Now, that line is actually just, where's my little whiteboard text gone? There it is. And was there the spare copy for Bella? Is there another copy for Bella? There we go, Bella. That line there is when we hovered over it, what did it show us that it was? 10x plus 20y equals 140. That's that line, equals 140. But the area that's less than it is all of this below it. This other line here is, see how it highlights it? 6x plus 8y equals 72. That's that one there. What do all those dots represent? What does that little coloured section represent?
Different amounts you can. Different. Sorry, like different numbers of each bags you sell.
Yeah, different combination of bags. So if I hover over one, you know, it shows that point there is the point 1, 3. That point there, so 1 of bag A, 3 of bag B, 2 of bag A, 3 of bag B, 3, 3. These are all combinations of bags that you can sell. I heard someone over here say the feasible region. You might have seen that on the front page of the booklet. This is what we call the feasible region. If something is feasible, what does that mean? It can be done. Yeah. You know, you could call up your mum and say, "Hey, mum, is it all right if I go to my mate's house tonight?" She could say, "Yeah, that sounds feasible." Probably won't, but she could. Or likewise, tonight, you know, your dad could say, "Hey, is it all right if you cook dinner?" Why don't you try responding with, "Yeah, that sounds feasible." They'll probably go, "What? Where have you got that phrase from?" If something's feasible equals possible, able to be done. You know, it's all good. It's feasible. That's what feasible means. So this feasible region are all the possible combinations of bags that you can sell. This is all of the different combinations, which is a fair few there, isn't there? Remembering that this is actually showing us whole numbers, because in this context, you can only sell like a whole of a bag, can't you? But really, that whole region is what we call the feasible region. So that's us doing it digitally, but let's now just graph it ourselves, okay? Now we can kind of cheat here, just to make it a bit easy. Can you see how the maximum there is 10 and the maximum over here is 15 on our y-axis? So when we go to do this ourselves, I'd encourage you to use one grid line per number. Your y-axis is going to need to go up to 10, your x-axis across to 15. So can you get 15 across, 10 up? And then let's get going with this. I'm going to find my little rule in here somewhere. There was actually room for me to use 2 grid squares for each one. But one per line is fine too.
5 would be certain food.
I think up to 10? Yeah. So let's label these four. We need to sketch these four constraints. Graph the constraints. The easy ones is x is greater than 0 and y is greater than 0. We've really already shown that, haven't we? X is greater than or equal to 0 is this line across here. That there, x has to be greater than or equal to 0. X is greater than or equal to 0. We know x has to be positive. And what was our second constraint? Y has to be positive as well. So is that's this one here, isn't it? Y has to be greater than or equal to 0. To be honest, showing those two axes actually just shows that anyway. That's what we'd call the first quadrant, isn't it? Although x is positive and y is positive. All right, let's graph these next two. Let's start with that one there. The 10x plus 20y is less than or equal to 40. 140, thank you. To graph an inequality, can everybody say inequality? This is an inequality because it's got the less than or equal to sign, or a greater than or equal to. To graph an inequality, all you need to do is first graph the graph if it was just equals. Just first graph it if it was equal to. Now we've done these before, haven't we? That's in general form. The simplest way of graphing a graph that's in general form is to find the intercepts. So the x-intercept for this one is going to be, remember you cover it up, 10x equals 140. So the x-intercept is going to be 14. So to do this, I'll show it over here. 10x equals 140. To find the x-intercept, you get rid of the y. 10x equals 140, you divide both sides by 10, x equals 14. So the x-intercept is 14, and the y-intercept, you cover up the x. 20y equals 140. So y equals, divide both sides by 20, 7. So our y-intercept is 7. So we now mark those points on our graph. X-intercept is 14. Y-intercept is 7. And then join the lines together. I'm going to need to find a ruler. I didn't bring that. Oh, there's one right next door, so I'm just going to grab one from next door. Here's mine. Fancy little ruler. Let's try that. Okay. There we go. So that is, let's write it. 10x plus 20y equals 140. Who can come and show us how we do this one? 6x plus 8y is less than or equal to 72? Any volunteers? Means you can stand up, stretch, come up and show us. Teach the class.
Wouldn't it be 9? Why would it be 9?
Y would equal 9. Y would be 9. You're correct. Let's start with the y-intercept. Elijah says the y-intercept is 9 because 8 times what equals 72? 8 times 9. So the y-intercept is 9. What's the x-intercept? 6 times what equals 72? 12. We find what those two intercepts are. What do we do next? Plot it. 12 and 9. Then you get your graph. Here we go. And then let's label it as well. What could I label that line as? 6x plus 8y.
Less than or equal to 7.
Is the line less than, or is the line... The line's technically equals 72. To show the less than bit... Oh, that was a loud noise. We can now shade the feasible region. Remember, the feasible region is everything above x, everything above y, and less than these two lines. Remember how it was less than? So if you have a coloured pencil, you are welcome to use that coloured pencil to shade this region, or even if it's just a lead pencil. That's our feasible region, isn't it? Joaquin, what did we say the word feasible means?
Possible.
Possible? Yeah, possible. Okay, so all of those results in there are feasible. And have we labelled the lines? Yes, we've labelled the lines. Label the x and y axes using words. What does our x-axis represent? Hint, hint, you could go back to your previous page. Number bag A sold. And our y-axis? Number of bag B sold, good. Just going to grab a drink of water so you can catch up. What's the next question say? Label the points of intersection of the lines around the feasible region. Label the points of intersection around it. Let's start with where these two lines meet here. What is that point right there? The intersection point? 8, 3. Looks like 8, 3 to me. How could you know for sure that it's 8, 3? Put into the equation, yeah. Possibly with those two, that put it in your equation solver, simultaneous equation solver. You know, put it in the matrix form. It helps you find that. Now, what are our other points that we've got here? We've got 0, 0 over here in the corner. What's this point just here? 0, 7, good correction, well done. And then over here we've got 12, 0. Okay, let's just tick that we've done those questions. Tick, tick. So all of these points, all points in feasible region show, what do all the points in the feasible region show? Combinations, I think I heard the word combinations. Show combinations of what? The bags that can be sold. Yeah. That's really what the feasible region shows. So all points in the feasible region show these combinations of bags that can be sold. All right, we've covered a few things so far, but what I want you to do right now is I want you just to put your pen down and I want you to find somebody in the back row, if you're in the front row. If you're in the back row, I want you to find somebody in the front row. I want you to stand up. I want you to talk about what we've learned so far. What things we've covered so far, what's new, what have we got so far. So stand up, find someone in the other room, let's stand up, let's move, and have a quick discussion. 30-second discussion about what we've learned so far. Go. It's going to start. Can you, which of them is, I don't want you to decide. If you know top goal, just run as fast as you can. What if it looks in draft? Good draft. Nothing. How so nothing? What are some of the things that we've covered so far? What does the shaded part of the graph represent? Which means what? Sure. Okay, we'll unpack that a bit more. What it shows all of the combinations of bags that can be solved in this the solutions that are possible. Yeah. All right, let's grab a seat. Let's grab a seat. Now, what was Precious and Eliza's ultimate goal today?
Maximize the income.
Maximize their income. So they want to try and maximize their income.
So always questions are worth.
Okay? We're going to get there. So they want to maximize their income. The question now is, so how many of each bag should they sell in order to maximize their income? We're told that all of these combinations are possible combinations. So we want to find the midpoint, as you guess. So just as so we understand this. 0, 0, that's in the feasible region. Right on the edge. The edges count as well.
Wow, that makes $0.
They'd make $0 if they sold that. What about, let's go this point here, 1 and 1. 1 and 1 is in the feasible region, isn't it? How much money would they make if they sold one of bag A and one of bag B? $20, wasn't it? Was it 12 and 8?
Yeah.
Am I right in saying, what about 2 and 2? 2 and 2 is in the feasible region, isn't it? They make 40. Okay, what about this point here? 4 and 2. 4 and 2 is in the feasible region, isn't it? So 4 of bag A, 4 8s are 32. Yeah, $56. Okay. There's lots of combinations here, aren't we? We're probably going to be here all day if we look at all of these combinations. Do you think it's going to be a result down here, or do you think it will be a result a bit higher up?
A bit higher.
Why do you think higher up?
So you're selling more.
Selling more, probably. Yeah, it's probably right. So it's probably higher up here. Okay. Or could it be this one over here? What about just sell 12 of bag A? 12/8 are
further away from the origin.
96.
Yeah.
That's a pretty good amount of money. What about if they instead sold 7 of bag B? 12 times 7 is 84. All right. Now, there's lots of combinations here. I'm going to tell you this. Mathematicians have looked at lots of these types of problems, and they noticed a pattern. The pattern was that the minimum or the maximum result always occurs at a certain spot on the feasible region. It always occurs at a certain spot on the feasible region. And the certain spot that it always occurs is...
Is it the point the two lines meet?
It's at a point of intersection. Correct. What made you think that?
I don't know. It's just because, like, I don't know.
Don't know?
Makes sense.
A good guess, yeah. The maximum or minimum of the objective function always occurs at
Oh, the point of intersection.
a point of intersection or one of the corners, which really is a point of intersection still, isn't it? Point of intersection / corner. So in other words, and I love how I can see people writing extra notes as we sort of go through this and see it. Okay. How many possible points do we need to look at? This one,
5.
this one, this one, and this one. And there is a special name that we give to those points, beginning with V. Yeah, vertices. All right. Vertices is the plural, but one of the vertices is called a vertex. Okay. So the green points, or a vertex, is what it's called. The green points are these vertex is the singular, vertices is the plural. Okay. A vertex is a corner. There are multiple vertices in there. Okay, everybody say vertex. Vertex. All right. So the next question tells us list the coordinates of the vertices for the feasible region. Okay, what are these coordinates for the vertices? Let's do that first bit. List the vertices. I'm going to start down here. 0, 0 is a good place to start, isn't it? What's next? 0, 7. 8, 3. 12, 0. That's it, isn't it? I think that the table just makes it look like there's going to be a fifth one. But there is only 4 spots, isn't it? Okay, so we only need 4. Hey, when you're writing a coordinate, can you please make sure you put brackets around it? Because that's showing good mathematical communication. So put the brackets around a coordinate. The next part of the question says, Joaquin, can you read the showing calculations bit?
Showing calculations determine how many of each gift bag precious analyzer should sell to maximize their profit.
Cool. Now, what does this table hint at us that we need to calculate? The value of 8x plus 12y. Why do we need to calculate the value of 8x plus 12y? That's the cost of it's the income, isn't it? That's how much money they make. So what's the value of 8x plus 12y when they sell 0 and 0?
0.
What's 0? That one's nice and easy, isn't it? It's nothing. Clearly it's going to be $0. What about 0 and 7? 8 times 0 plus 12 times 7 equals $84. What about 8 and 3? 8 times 8 plus 12 times 3. 8 times 8 is 64. 12 times 3, 36. We've got 100. Hundo, as Hamish and Andy would say. And what about 12 and 0? 8 times 12. Is it $96?
Yeah.
All right, we've worked out the coordinates of the vertex. Remember, mathematicians have proven this. I wish if we had like time, all the time in the world, we'd explore this a lot more, we'd do it. Your book goes into more detail on it if you really want to understand the why behind it. But the maximum or minimum always occurs at one of these vertexes. So it means it just narrows down what we have to explore. So which combination should Precious and Eliza aim to sell?
8 and 3.
8 and 3. Why should they do that?
So,
It's saying max profit. So we could say, therefore, maximum occurs at 8, 3. So that's where the maximum occurs. Let's answer the question. Determine how many of each bag they should sell. Therefore, they should sell. Let's write it in words. 8 of bag A and 3 of bag B. Gosh, that's a lot of work just to get to that point there. Ideally, that's how many they should aim to sell, and they'd maximise their profit, wouldn't they? Folks, in a nutshell, that's a quick overview of linear programming. We started off swimming in the toddler pool, didn't we? And we've really jumped into the adult pool today, haven't we? Yeah. All right. I want you to have a go. I think you're ready to have a go by yourself. Well, you're not by yourself because you do have your partner next to you. If you want to actually work on the next question together, I think you're going to question 2, which is over the page. All right.
Yeah.
It's a similar structure. I've sort of structured this question very intentionally. Yeah.
More questions.
It's got a couple of other questions on the back, yeah, which I expect those couple of questions over the back people might have questions on.
Okay.
It means then we can go through that together. Okay?
Perfect.
So if you have problems with it, great. Then that means we can work on it. Alright, so have a go now at question 2.